Math 1314, Tyler Junior College, Section 2.4, More About Slope. In the previous series of videos, we did a fairly thorough analysis of linear functions, algebraically functions who are polynomial but the highest power is 1. We learned how to calculate slope, what slope was. We learned about slope-intercept form, point-slope form, general form. We learned about graphing lines. We learned about writing equations of lines. We also talked about horizontal and vertical lines. But in this section, we're going to talk a little bit more about slope in a few different contexts. One context, of course, is going to be parallel lines. As you can tell, I have 2 videos planned for parallel lines. For example, the equation of the line, find the equation of the line that passes through the point 1, 3, so I've already got it there, and is parallel to the graph of y equals 2/3 x minus 5, which I've already drawn here. Answer in slope-intercept form. Just a reminder, we can sketch the graph of y equals 2/3 x minus 5 pretty quickly. The minus 5 being the y-intercept is a good starting point, and then the slope being the coefficient of the x 2/3, interpreted as a rise of 2 and a run of 3, take us to a second point. But we don't want the equation of the red line, I gave it to you. We want the equation of a line that's parallel to it and passes through the blue dot. Now, what does it mean for 2 lines to be parallel? Most people have an intuitive idea of what it means to be parallel. The top of this board is parallel to the bottom of the board. The 2 sides of this yardstick are parallel to each other. If you could look down and see the tiles on the floor, you'd see lots of parallel lines, or the lights up on the ceiling. But if you were to give a rigorous definition, how would you define it? What are parallel lines? What do they do? Or equivalently, what do they not do? For example, this x-axis and this y-axis are not parallel because they intersect. So parallel lines are parallel if they are non-intersecting if they do not intersect. But what does this have to do with slope? Remember, slope is a measurement of steepness. So if I want to draw a parallel line through this blue dot that's parallel to the red line, I know they can't intersect, so they have to be about like that, but what does that say about their steepness? Which one is steeper, the blue line or the red line? Well, if they're parallel and they never intersect, then they need to have the same steepness, don't they? Because, for example, if the blue line were steeper than the red line, then they would intersect down here, but if the red line were steeper than the blue line, they would intersect over there. So the only way these can be parallel is if they have the same steepness. But since slope is a measurement of steepness, we can conclude that parallel lines have equal slopes. I think that's fairly intuitive. If you're parallel, you have the same steepness, therefore you have the same slopes. So how would we go about answering this question about the equation of the blue line that's parallel to the red line, whose equation is y equals 2/3 x minus 5, but simultaneously goes to the point 1, 3? Well, in the previous series of videos, we discussed how to build the equation of a line. Most of the time, unless you happen to know a line's y-intercept, and good luck guessing this one, it's a fraction, it's not an integer. But if we're going to build the equation of a line, we're probably not going to start with slope-intercept form, but we can almost always start with point-slope form. So we're going to use point-slope form. Now, for point-slope form, I need a point and a slope. Clearly, I have a point. Well, what's the slope of the blue line? The same as the slope of the red line. And what's the slope of the red line? 2/3. So, since the lines are parallel, actually what I'm writing now is what you would think, but for instructional purposes, I'm writing it on the board. Since the lines are parallel and the slope of the given line is m equals 2/3, then the slope of the parallel line, P-A-R-A-L-L-E-L, is, now I'm going to introduce a symbol that may look new, but it actually makes sense. To represent a parallel slope, I'm going to use the letter M, but I'm going to subscript it with the symbol for parallel, which is two vertical lines. So when I write M subscripted parallel, I'm just saying the parallel slope is the same as the original slope, which is 2/3. So now I know what I'm going to use. I'm going to use the point that I was given, and I'm going to use the parallel slope of 2/3. So our point slope form is y minus the y coordinate that we were given. Well, just as a reminder, point slope form is y minus y1 equals m times parentheses x minus x1. So the y1 that we were given in the point was 3, so y minus 3 equals, the parallel slope is 2/3, open parentheses, x minus the x coordinate I was given, which was 1, and we're almost done. Because although we have the equation, we were asked for the equation in slope-intercept form. So we need to convert this to slope-intercept form by solving for y. That would require distributing the 2/3. So 2/3 x minus 2/3 times 1 is 2/3. And then adding 3 to both sides. But let's think about this. When I'm adding over here, I have fractions, so I need to think of the 3 as a fraction, 3/1. And I need it to have a common denominator. That denominator is 3. So if we multiply both sides of this fraction by 3, we get plus 9/3. So we have y equals 2/3 x. All right, time to think for a second. Negative 2/3 and positive 9/3. First off is positive because 9/3 is larger in size. Secondly, the common denominator stays 3. And thirdly, negative 2 and positive 9 is positive 7. So that's why we couldn't just spot the y-intercept, because its y-intercept was 7/3. So to find the equation of a parallel line, all you need to know is the original line's slope. Because they're parallel, you use that slope, and then it's business as usual. That is one messed up looking 3 under the 2 in the slope.
Ah, well.
It happens.